Hello dear students, this is Raksha Shetty and you're watching Edubassa, your homely learning channel. So in the last video we learned about the characteristics of the properties of matter, and today in this video we will be concentrating on the states of matter topic of the chapter matter in our surroundings. So without further ado, let's get into the video. So these are the content part. In this video we are going to learn about what are states of matter, what do you mean by solid state, what is liquid state, which are the exceptions as well as the examples, what do you mean by diffusion in liquids, the gases of state, properties of gases, real life examples of the gases, and the particle arrangements in the states of matter. Yes, so let's get into the video. What are states of matter? What do you mean by states of matter? Matter you already know, isn't it? What is matter? Anything which has mass and which occupies space is matter, which we already learned in the previous video. So if anything has mass and if it occupies a particular space, then it is said to be a matter. Everything around you is matter. The universe is made up of matter, isn't it? The pen you're writing in is a matter. You're watching this particular YouTube video using a phone, isn't it? That also is a matter. Am I right? So you might feel thirsty and you might drink the water right now, isn't it? So that is also a matter. And the air that you're breathing in, that is also a matter. It has mass and it occupies space. So all of these are matter. Am I right? Now all of this matter, be it the phone, be it water, be it the gas, the air, the oxygen, all of this exhibit in the different states, right? So these are nothing but the states of matter. Okay, these are nothing but the states of matter. So the commonly seen as solids, liquid and gases. So these are the three states of matter: the solids, the liquids and the gases. And all of this will be having the unique properties in the sense all differ from each other. There are the different properties for each one of them, right? So they are having the unique properties. So first let us learn about the basic one, which is nothing but the solid state, isn't it? So the pen that you're writing in and the phone that you're seeing this video is a solid, right? It is a solid. It has got a definite shape, it has got a definite volume, isn't it? The mass will be the same, isn't it? The mass will not change. It has got definite volume, it has got definite shape. The shape will not change easily. For example, if you try to press your phone, what happens? Will it change the shape? Obviously no, it don't, isn't it? That easily it will not change the shape. So it has got a definite shape and it has got a definite volume. Does it flow? Obviously no, it does not flow. Why does it not flow? Because here the particles are tightly packed. Here the particles are tightly packed, and that is the reason it has got the definite shape and it will not move. It will not move in the sense it will not flow. Okay, it will not flow. Yes, it is rigid in nature. It is very rigid, isn't it? It is very strong, isn't it? It is very rigid in nature. Can we compress the solids? No, it is very difficult to compress the solids, right? It is difficult to compress the solids. All of the there are a lot of examples for solids, be it book, the chair you're sitting on, the pen, what else, the phone, what else, everything, isn't it? Most of the things are made up of the solid. I hope you understood this. So this is very simple concepts. Okay, so one thing is it has got a definite shape, it has got a definite volume, and it is very rigid in nature and it do not flow, and we cannot compress the solids, right? Yes. So with one experiment we will understand it better. So I am going to take a book, I am going to take one wooden block and a pen. I am going to try to compress that. I'm going to try to compress that, make it, compress it, or by using a hand or by using the hammer. What happens? Will it be compressed that easily? Obviously no. Solids do not change the shape or the volume that easily because it has got definite shape. It has got definite shape because the particles are arranged very tightly, right? So next is about the liquid state. So the liquids has got the definite volume but not the definite shape. The volume will remain the same. Okay, for example, just take a one just imagine this is a bottle. Okay, yeah, so this much amount of the water will be there, so I'll be taking one more container and I'm going to pour this the amount of water. Just imagine 1 liter of water is present over here, so I am going to pour this water to this beaker. What happens? Will the water change to 2 liter? No, it will be 1 liter itself, isn't it? Yes, so the volume is definitely going to remain the same, but the shape is no definite. It changes, isn't it? It take the shape of the container. If it is the rectangular shaped bottle, it will be in a rectangular shape. If it is some square shaped container, it will be in the shape of the square shaped container. The thing is, the volume will remain the same. The volume won't change, but the shape will change, right? So it does not have a definite shape, and it can flow. Unlike the solids cannot flow because the particles are tightly packed. Here the particles are bit loosely packed. Okay, it is bit loosely packed and there is a space, isn't it? So it can easily flow. It can be easily flown. Okay, fine. And it is not rigid like solids. It is not rigid like solids, and it can be compressed slightly. It can be compressed for a level. It can be compressed. Yes. So there's one activity. So first I'm going to collect some of the liquids, be it milk, water, juice and oil. All these are liquids, am I right? Whether any of these are solids? No, all these are liquids. So I am going to take all of these liquids and I am going to pour all of these liquids to different containers, 4 different containers. What happens? All of these liquids will take the shape of the container, but the volume is going to remain the same. Am I right? The volume is going to remain the same. So this is one of the activity, right? Next is about some of the exceptional cases, some of the examples for the exceptional cases. Rubber band. So rubber band is a solid, right? It is a solid, but it do change the shape. It do change the shape, right? Right, when you just pull your rubber band, it does, pull in the sense when you stretch the rubber band, what happens? It is going to change the shape, isn't it? So it is not a property of solid. It is not a property of solid. So it is not a true solid. We call it as a elastic solid because it is made up of chain polymers. Okay, so hence it can be stretched, so it is elastic solids, right? There's one more exception called as sugar or salt. Sugar and salt is nothing but solid, but when you add the sugar and salt to the water, what happens? It dissolves, isn't it? It dissolves in the water. It takes up, if this is a water, the particles are loosely packed over here. When you add the salt or the sugar, it takes up the spaces in between the solids, right? And gets dissolved. Okay, that is one more exceptional case. And the oxygen and the carbon dioxide, this is the gas, and about the gas we are going to learn further. So this is not solids, right? They are the gases. So these gases are basically dissolved in what? Dissolved in water. You know, isn't it, that the aquatic animals, they take up, they also breathe oxygen, isn't it? From where they get the oxygen from? They are respiratory system is in such a way that they can take up the oxygen which is dissolved in the air. They can take up the oxygen which is dissolved in where? Dissolved in the air, right? Yes. So some of the extra points, students. Rate of diffusion in the liquids is higher than that of the solids. So the rate of diffusion, you might have learned in the previous video, the diffusion is more in liquids. Okay, it is more in liquids compared to that of the solids. The diffusion rate is in the liquid is more. Okay, the diffusion rate in the liquid is more. Just imagine, I'm going to put one ink in that of the water, isn't it? It will spread evenly. So the diffusion rate in the liquids is more compared to that of the solids, right? And the solids are rigid, whereas the liquids are fluid, and the gases are highly compressible, right? So next is about the gaseous state. So talking about the gaseous state, the properties of the gas is so it is unlike solid and liquid. It nor has definite shape, nor has no definite shape, no definite volume. Okay, no definite shape, no definite volume. Okay, so it will take up the entire space and it can be compressed. It can be compressed. It doesn't have any volume, proper volume. It can be filled up in the container, and it takes up the entire space of the container. There is no definite volume for that. Okay, why? Because here the particles are very much loosely arranged like this. The very much loosely, if this is the gas, it is very much loosely arranged. Okay, hence it takes up this entire space of the container. And the thing is, it can be compressed easily. It can be compressed. The high compression can be taken place. All these compressed gases can be used in the LPG, CNG and all, which we will learn for the real life examples. Yes, understood. Yes, so it can be highly compressible. You might have seen, isn't it, the balloon, it is filled with the gases, and the LPG, the cylinder that you use for the stove, is filled with the gases. All these gases can be compressed easily, and they easily expand and it spread in all the directions, because here the particles are very far away from each other and they do move really fast. Okay, they move really fast. Yes. Next activity, we are going to take the two syringes, injection syringes, which mostly looks like this. I'm so sorry for the bad diagram, but mostly looks like this. Yes. So one I'm going to take up the empty syringe in the sense, obviously the air is present. Okay. And one more, I am going to take the syringe that is filled with that of the water, liquid. Okay, now tell me, when I press this piston, what happens? The water will compress a little, whereas the air will compress a lot, right? You can do this experiment if you have syringe, but while handling the syringes, please be careful. You please take the needle and use it. Okay, so it compresses easily. Water will compress little lesser compared to that of the air. From this experiment, what you can understand, that the gases are highly compressible than that of the liquids, right? Yes. Okay, so from all this, what we are going to learn is nothing but, see, gases are highly compressible, understood, compared to that of the liquids as well as solids, that is understood clearly. So examples of the gases in the daily life is the balloons that is filled with the gases, hydrogen, helium gases, right? CNG, that is nothing but compressed natural gas, which is used in the automobiles, vehicles, isn't it? It is of the low cost, hence it is used. Okay, and that is also a compressed natural gas, right? It has been compressed and filled to that of the cylinders. LPG is liquid petroleum gas that you use for your stove to cook, isn't it? So that is again what, compressed and kept it inside that of the cylinders. And the oxygen cylinders for that of the hospitals, that is also again what, oxygen is a gas, right? So yes, so these are the examples in your daily life. Then is about the arrangement of the particles, how the particles are being arranged, which we have already discussed. Once again we'll discuss. In the solids, the particles are tightly packed and they are in the fixed position. These particles will not move, isn't it? They are in the fixed position. They cannot move it itself, so it is tightly packed, hence it cannot move. It is in the fixed position. Whereas liquids, the particles are close but not very close. Okay, close but not very close, but they can move a little. They can move around each other, like it can move here, right? This is what liquids, in the case of the liquids, hence it take up the shape of the other containers. Talking about the gases, here the particles are very far from each other, so it moves really freely. It moves and it moves with high speed. So with high speed, just imagine there is traffic. Okay, so there is traffic, there are lot of vehicles present on the road. It is very difficult for you to move, isn't it, when the traffic is more? But if the traffic is less, just imagine in the road 1 or 2 vehicles are only present, that obviously you can move fast, isn't it? The same way here the particles are very less, hence very less in the sense very far away from each other, and hence you can move easily. Whereas in the liquids, the particles are close, not very close, hence they can move easily, but not as that of the gases. In the case of the solids, the particles very tightly packed. It will not move an inch. It is in the fixed position. Yes. So this is how the particles are present in the solid, and it is how it is present in the liquid, little bit far away from each other. If I have to see the gas, it is like this, okay, very far away from each other, like this, okay. Yes, that's about it, my dear students. So matter is everywhere, changing shape, mixing or moving, but it never disappoints. That's it for today. Let's meet again in the next video. Please do not forget to like, share and subscribe. Until then, keep watching, keep learning, and very, very importantly, my dear students, enjoy while learning. See you. Bye bye.